Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. So we are into unit number 4 and we are discussing about pushdown automata. And now this is actually lecture number, or you can say part number 4, part number 5, where we are dealing with two-stack pushdown automata. Actually, this is an extension of this unit. Generally, the questions or the examples will be asked from pushdown automata only. But you should have an idea about two-stack pushdown automata and its implementation. In certain languages, you need the help of two-stack pushdown automata because it becomes a little bit difficult to complete or to construct a PDF for those type of examples, so for those type of languages. Okay, and those languages I will let you know now. Okay, so basically this two-stack pushdown automata is similar to the pushdown automata only, but here only one difference lies is that we will be using two stacks in place of single stack that we have used in pushdown automata. Okay, so this is the only difference, and one more difference we will check while describing the formal description of two-stack pushdown automata. Okay, so if you check with the definition, a two-stack pushdown automata, generally we write as two-stack PDA, is similar to a PDA, I have already told you, but it has only two stacks instead of one. So in each transition we must denote the pop and push action on both the stacks. Clear? So that means here we will be using two different type of transitions, one for stack 1 and the other for stack 2. I will let you know the diagram as well where you can understand easily. But if we talk about the diagrammatic representation or graphical notation of two-stack pushdown automata, it is like this. On seeing the input symbol A, okay, we can have two operations simultaneously. Okay, this may be in stack 1, this may be in stack 1 and this may be in stack 2, where in stack 1 B is popped off on the first stack, and automatically C is pushed into the first stack, and similarly you can work it out with the second one as well. So this is just a basic example. Okay, we will let you this is just a basic diagrammatic representation. We will take an example and I will explain the flow as well, okay, how to work on it. Okay, now if we talk about the mathematical or the formal description of two-stack pushdown automata, only one difference lies. Now in pushdown automata, what happens? How many tuples are there? 7 tuples, correct? But in two-stack pushdown automata, we will be having 6 tuples. Why? Because in general pushdown automata, in the stack we used to take a start symbol, that is Z0, correct? But here we will be having two stacks and we will consider both the stacks as empty, and we won't be taking any start stack symbol. Clear? So I will also let you know the formal description. Okay, so this is the formal description where I'm having 1, 2, 3, 6 tuples. Okay, where all the tuples are similar to your pushdown automata only. Only Z0 will not be there. That is the start stack symbol. So these are the attributes of these particular tuples. Okay, no, you can note it down also. Already you know it. Q is the number of states. Again, I'm repeating. This epsilon is nothing but your sigma is nothing but your alphabet of input tapes. Then gamma is nothing but your the stack alphabets. Correct. This is nothing but your transition function delta. Q0 is the start initial states, correct? Initial state or start state, and this is your final state. Here, and if I talk about the transition function, if I define the transition function is defined by this. Okay, that means Q is the total number of states multiplied by the total input alphabets multiplied by both the stack alphabets. To the power asterisk means you can have any number of stack alphabets, right? Asterisk equals to 0 means the stack is empty, correct? Asterisk equals to 1 means first and second. First symbol of the first stack, first symbol of the second stack. So this process goes on. Implies only we have to consider the states and the stack alphabets. So this is the transition function all about. But this might be a little bit difficult for you to understand. So we will take an example and I will let you know. Okay. So this is the general formal description of a two-stack pushdown automata. So now let me define to you the diagrammatic representation of the push down automata. So if I talk about the general block diagram will be like this, okay, where the input tape will be there, which we considered as an infinite input tape, where your the strings will be there, correct? Then the finite control machine, okay, and in place of one single stack, we will be having two stacks. Clear? So this is the block diagram. Okay, now let us take the example which we are waiting for to understand better. Okay, so let me take an example, and the example is like this. The example says that the language is given to you a to the power n, b to the power n, c to the power n, where n is greater than equals to 1. And we have to construct a two-stack PDA. Why? Can we draw with the single stack single PDA? No. Why? Because if you check with this particular A, after scanning or after reading all A's, we can push into the stack. But once in one stack, I'm talking about, right? Once when we reach B, then automatically A we need to pop. But what happened to C? How can we read this C? Correct? So this is a little bit difficult with two-stack PDA. Okay. Yes, we can simply read the C and we can miss the transitions. Missing the transitions means we can skip the transitions. Okay, that also we can do, but that is a little bit difficult to work on. Okay, so better to use two-stack, and then we can implement that. But these all languages will be easy when we reach on to unit number 5, when we will learn about the most powerful machine, that is Turing machine. These examples will be very easy for you that time. Okay, got it? So in two-stack PDA, what we will do is that once we read the A, then we will push all the A's into first stack, correct? And once we start reading B, okay, we will do two simultaneous operations. For stack number 1, I will be popping, and stack number 2, I will be pushing B. Correct? That means parallelly, while popping all the A's, B will be pushed into stack number 2. Clear? Then again, on reading C, I will pop all the elements from stack number 2, that is B. So all the elements will be read properly. Clear? Again, I am repeating what will be the process. On reading all the A's, I will push into stack number 1. Clear? And once I started reading B, I will do two parallel operations. One operation is that I will pop one after another all the A's from stack number 1, and while popping, I will push these B's into stack number 2. And once I reach C, what I will do, that means stack number 1 empty, it becomes empty after pushing all the B's, correct? And once I start reading C, what I will do, I will pop each and every B once we will encounter all the C's. That means all the A, B and C will be read properly according to the operation of push down automata. Clear? So this is the general concept behind the two-stack push down automata. So let me explain to you how to draw this. Okay. So according to the language, I have defined particular strings. You can also identify like n equals to 1, then a, b, c, n equals to 2, then a, b, b, c, c, and so on. Correct? So how to work on this? Now suppose we are considering this particular string. 4 times a, 4 times b, 4 times c. Or let it be, I will consider this entire string, entire language, and I will draw the two-stack PDA. Okay? Let me take an empty page and I will draw it. Okay, so I'm having with this particular page and I will draw the two-stack PDA. So what is the language given to you? The language given to you is L is equals to a to the power n, b to the power n, and c to the power n. Correct? Sorry. A to the power n, b to the power n, and c to the power n. Clear? Now if I take the input tape, I can take like this. Okay, sorry. Again, I am writing down. Suppose the language is given to you is a to the power n, b to the power n, and c to the power n. So the input tape will be like this. Clear? And this will comprise of a n number of times, then b, suppose I'm taking 3 A's, okay, and then b n number of times, and then c, okay, n number of times, and then we will reach epsilon. Clear? So this is the input tip, correct? Now what I have to do, I have to use two stacks which I have used. Stack number 1, clear? And this is stack number 2. Clear? So this is the basic requirement I did. Now I will draw the diagram one after another. Okay. Now if I talk about this particular string, the initial state will be like this. Okay, I'm taking suppose Q0 as the initial state, correct? So what I will do, I will start reading this A, correct? I will start reading this A. So as you can analyze after constructing PDA, all these A's will be in a self loop, correct? I can use a self loop and I can push all the A's into the stack, correct? And where all these A's will go? All these A's will go to stack number 1. So I can take a self loop and I can do first on seeing A, correct? Now one more thing I want to discuss with you all, the format of this transition. Okay, how to draw the format, okay, that I haven't explained. Now if I write like this is the transition. Okay, we will be having 3 operations. Suppose I'm talking this, then I'm doing like this. Okay, I'm taking like this. Okay, now this element is your input element that you are reading. Input element read. Okay, now this the second one. Now the second part of the first one is element at top of the stack. TOS means top of the stack. Okay, and this element means here element to be push. Okay, so if epsilon is there in place of this, that means you have to pop this. Clear? I have taken, that's why I have taken 2 things in one particular transition. Okay, again I'm repeating, A is the first part, is the element, input element to be read. Okay, now this part is for stack 1 and this part is for stack 2. Okay, and in stack 1 we will be having 2 operations. One is your first one is your element at the top of the stack, and second one is the element to be pushed. If there is nothing, that means you have to pop the element top of the stack. Clear? Same goes with this one. Same operation goes with stack number 2. Got it? This is the transition format. I will write it down. This is the transition format. Okay, now let us draw the diagram as according to the concept. Okay, so we are having this. So first of all, input element A. Okay, now at the top of the now next will be stack number 1 operation. In stack number 1 operation, element at the top of the stack generally empty, initially empty, right? Initially empty. Then what is the element to be pushed? A to be pushed. In the second stack, nothing to be done, remain as it is. Clear? So this is for the initial one, initial A. Now I have to take all the A's, correct? I have to read all the A's one after another until we reach B. That means one more loop will be there. On seeing A, what will be the top of the stack? A. Then what I will do? Then what will be the top of the stack is A. What is to be pushed? A. Then what will be done in the second stack? Nothing to be done in the second stack. Clear? So this way all the A's will be pushed. Clear? Now, okay, now all the A's will be, now if you check into this transition, all the A's will be inserted into stack number A1. That means A like this. Clear? Now all the A's, after finishing all the A's, what will be reaching? Will be reaching B. So for first B, the state will be changed from Q0 to Q1, correct? So what will be the diagram if I ask you? What will be the transition? Now what will be the input symbol? B. In stack number 1, what will be the operation? What is that element at the top of the stack? A, correct? What is to be pushed? Nothing to be pushed. Epsilon. This means A will be popped on seeing the first B. And automatically in the second stack, what will be the top of the stack? What will be top of the stack? Epsilon. What is to be pushed? B to be pushed. Clear? So automatically this B will move to this B. Clear? So top of the stack is eliminated and B is also pushed into the stack number 2. Now this process will continue here until we complete all the B's. That means on seeing B, correct, input symbol B, stack number 1, what will be the operation? Same, top of the stack is A, epsilon means A will be popped. So this A will be popped, right? And what I have to do? I have to do the push operation. So if I do the push operation in the stack, second stack, this will be like this. B, B, then B, 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 like this. So I have noted down only 2 B's here. Okay, it depends on you. You can also mention only single B also over here. Okay, this means B is again pop, push, and A is popped. Clear? So this will be acting in a self loop. So all the B's will act like this. So B will come over here, A will be popped. So like this entire operation will be done in stack number 2. That means all the B's will be read. Clear? Till now it is clear. A is I have pushed first, then on seeing B first, I have popped the A first, top of the stack, then parallelly I have pushed B into the second stack. Clear? Same way I did for entire B's. Correct? Now the next transition will be what? Now the next transition will be for C. So on seeing C, what is the top of the first stack? Stack is empty now. Stack 1 is already empty because all the A's has been popped up. So stack 1 has been finished. Clear? What is now stack number 2? Now if I talk about stack number 2 will be left out with. Stack number 2 will be left out with. What is the top of the stack? Top of the stack is B. Correct? And the any element to be pushed? Nothing. That means B epsilon. This means on seeing the first C, top of the stack B will be eliminated. Now can you let me know the next state? Next state is Q2. So this will operate like a self loop. So in self loop, what I have to mention, on seeing C, first stack is already empty. Correct? In second stack, top of the stack on seeing B, I have to pop. That means all the B's will be popped once I have done reading of all the C's. So can you just let me know that this is the final state? Because the entire thing is done. So this will act as your final state. So this is the initial state. Okay. And this is your final state. Clear? So this is your entire diagram for your 2-stack PDA. Again, I'm repeating over here. These are the input symbols: A n number of times, B n number of times, C n number of times. Okay, and this is the epsilon. This means that entire string has been read and I have reached the epsilon. This is the final state. Correct? Now I have taken 2 stacks, stack 1 and stack 2. Clear? Initially I have taken the state as Q0. So initially, first symbol that I will read is A. Correct? On seeing A, correct, inputs element, what is the next phase? Next phase is for stack number 1. In stack number 1, what I will do, top of the stack is already empty. What I am pushing? A. And in the second stack, it is already empty. Clear? So that means first A will be pushed into stack number 1. Clear? This way I will use the second transition for A. Top of the stack is A. What I am pushing? A. And what is in the second stack? Nothing is in the second stack. That means all the A's will be pushed one after another into stack number 1. Clear? Now we will reach stack the next element, that is your B. So on seeing the first element B in stack number 1, what is the top of the stack? A. Now what I am using in push operation? This epsilon. This means that I will pop this A. That means on seeing B, first I will pop the A which is at the top of the stack in stack number 1. And simultaneously in stack number 2, what I will do, I will push this B. Clear? So this means that two parallel operations are going on. Clear? Now similarly I will do for all the B's, remaining B's, correct? So I will take a self loop. In this self loop, on seeing B, in stack number 1, top of the stack is A. I'm popping out by using this epsilon symbol, correct? And in stack number 2, on seeing B, I'm pushing B. Clear? I'm using two B's, don't get confused. This is means the stack elements, okay? So I'm using only one B to make it clear, okay? Next, in this, as this is a self loop, all the B's will process like this. That means on reading B, A will be popped from stack number 1 and B will be pushed into stack number 2. Clear? In this way, all the A's will be popped out and B will be pushed into stack number 2. Now, after this, stack number 1 will be empty. Now we have to work on with only stack number 2. Correct? In stack number 2, now next will be what? After completion of all B's, C will be encountered. Correct? If I see first C, first stack is already empty, right? Then second stack, what I have to do? On seeing the first C, top of the stack B, I need to pop. Correct? And the similar way, I have to take a self loop and I have to do the same process. Clear? This until we read all the C's. Correct? That means first A will be pushed in stack number 1 and in stack number 2 I will do pushing operation of B and popping operation of A. That means after reading all the B's, the stack number 1 will be empty and then we will start off with input C, and once we start off with C, all the B's that are in stack number 2 will be popped out. This way we read all the elements from A to C. There. So thank you. So this is the general overview, or you can say the construction of two-stack PDA. Hope you have understood the video. You can pause the video, you can rewind the video. That is a very good benefit of learning through a video lecture. Okay. And if you have any doubt, please comment down below. That is my again query to you. Okay. And do subscribe my channel for getting the latest update videos. Okay. And we will, in the next lecture, we will check it out. The topic of pumping lemma for context-free languages. Thank you.